Number 21 discusses a series of resistors in series like this, a 10, a 15, and an unknown resistance R, all in series here. And it says that there's 100 milliamps or 0.1 amps running through the series here at a potential difference of at 5 volts. And would like to know what that unknown resistor must be in order for this to happen. So the way I would approach the problem is I would look at these resistors here as in series, as I mentioned here. So if you were a current trying to come down this resistor chain here, you'd encounter the 10 and you'd encounter the 15, then you'd encounter the R, and all of these things would be sort of an additive resistance you'd have to get yourself through. So the total resistance of this simple circuit here is 25 plus R. Again, resistors in series, you just add up the resistances here, and that's where you get the total resistance. So 10 and 15 is 25 plus R. There you go. That's the total resistance. So the way you can think about this now is you can think of these three resistors now as being replaced with a single resistor, looks like this, with a resistance of 25 plus R ohms. And it would be nice if R was known so we could state the number, but we don't. Just algebraically, we know this equivalent resistor here must have a resistance of 25 ohms plus whatever the unknown resistance is. But the fact still holds that of this unknown resistor here, the delta V, or the potential drop across it, is still 5 volts. And the current doesn't change either, so we still know that the current running through this resistor here is still the 0.1 amps. So essentially what we'll reduce the problem down to is a single resistor of resistance 25 plus R with a delta V of 5 volts across it with the current of 0.1 amps going through it. It's just a prime candidate for an application of Ohm's law. So you can take this whole system right here and say, you know that Ohm's law, delta V is I times R. That's Ohm's law. The delta V is 5 volts. The current running through it is the 0.1 amps. And the resistance that we're talking about here is the unknown, the 25 plus R. Now you have a single equation involving only the unknown R, and I think you can solve for that. If I do that, I get something like 25 ohms. So the unknown resistor in this network here, in this series chain network here at the very beginning here, must have a resistance of 25 ohms in order for all the other physical parameters to hold up the way they do.